Yes, hello. Welcome to my small presentation here about how to enhance user experience with always-on applications with data syncing. Yeah, it's nice to be here in Bratislava at OpenSlava 2022. Great to be here. My name's Alexander SCHLÜTER. I'm solutions engineer at Couchbase, and Couchbase is a technology partner of Accenture. And we're really happy to tell you a little bit about what we are doing, how we can help you to enhance your application and the experience the users got from it. And yeah, when talking about user experience, most people think about, let's say, front-end application, some nice, fancy user interface, some sophisticated functionality, AI, and so on. And yeah, so now there comes some from a company who provides a database and wants to talk about user experience. So how can the data layer help to enhance user experience? That's what I want to talk about. And when talking a little bit about Couchbase, I'm not sure if everybody knows us as a company. If you do not know us, it's likely that you have already used us without knowing it. We're the data layer backbone for operational data, for a lot of mobile application platforms, for a lot of web services that run globally, for different purposes, for different use cases that we have there. And let's see how data has an impact on user experience. Well, first of all, let's talk about how application needs have changed over the last years. And this has been really significant development that applications have gone through all the availability of mobile devices, web platforms, and so on. And I think, what are the requirements that I have if I want to develop an application, if I want to provide that? So this depends on who you ask. If you ask your product or program managers, they would say, hey, I want to deliver a great customer experience when I'm rolling out a new web portal or a new mobile app. I think the trend of hyper-personalization is one thing. Then application responsiveness is really a key factor to success for applications today. No one wants to wait today. So if you think about, if you really want to know or get to know someone just giving a slow internet connection, then you will really know that person, how he reacts on that. And the more we work together with mobile applications, with mobile devices, its data is anywhere and everywhere available. We need real-time information all the time. And on the other hand, we need to ensure the actions are still dependable that come from these kind of applications. So, but if you ask your developers, software architects, what would they say? They would say, hey, I want to develop just my applications quite efficiently. I want to accelerate my product cycles. I want to really fast pushing out my apps to the markets. On the other way, I want to use the skills that I've learned that I'm already using. So, for instance, in the database space, these are typical SQL skills. These are SDKs for different types of programming languages. Best practices of development should be supported, agile development, object-oriented technology, and so on. And of course, I want to avoid the data sprawl. I do not want to work with thousands of tools to handle my data. It's more better to have one, let's say, platform that gives me most services to handle data of my applications. Yeah, and then the last one is the operations part. So how can I deploy effectively applications? How can I operate and manage them? How can I keep them up for my users or customers? And that maybe also at a global scale, not only for a small installation. And as well, the management should be easy and most cost effective. Yeah, so applications needs have changed. And if I look here at typical customer-centric use cases that we have today, things like order management, payment transactions, shipments and shipment tracking, then we see today that all these kind of transactions and orders and transaction, that with this order, there come a lot of different interactions with it. So before a customer places an order over a web portal or e-commerce platform, there are click paths that I want to store. Where did he went through my offers? What were the search results he was looking for? Which products did the customer viewed? What reviews checked he? And so on. So on one single transaction, there are likely in the order of thousands of interactions that I want to store in a database. And if I look at mobile and IoT use cases, this ratio is even much bigger. To one maintenance of a industrial robot, there might be millions of sensor data records that I need to store. And you see that the amount of data and, of course, the time in which I want to store it, this has significantly changed in comparison to former solutions that are mostly also within an enterprise, or maybe not for an open public customer. So yeah, so with these application changes, also the requirements for a modern database have changed. So if you think about the legacy needs that are fulfilled from traditional relational database systems, these systems were very structured. Data structure was a very important thing. Transaction integrity was important, consistency, storage efficiency, so data unity and so on. That was all important. But modern needs have changed. And we have massive data, as we've seen here, for these customer and IoT use cases. And the thing is, how can a database scale and deliver the performance at any scale? So no matter if there are 10, 100, thousands, or even millions of users or customers that are using a web portal, that are using a mobile application, so how fulfill that? And also questions like, hey, when thinking about an e-commerce platform and I have that Black Friday situation just before Christmas and I need to handle a few million requests more, how can my database cover that? And also the question of flexibility, agile development methodologies should be supported. And of course, microservices architectures that have changed the access to a database as well, deliver much more interactions than traditional monolithic approaches. Yeah, last but not least, of course, that I need to cover web and, of course, mobile experiences to be supported. Yeah, okay, so how that these applications drive the need for a new type of database? If we think about the most important things, requirement for performance, for flexibility, for mobile and IoT applications, I think then that's the most important stuff we see here. And that, of course, to reduce the costs and make things also available as a service from the cloud. But okay, let's see how traditional relational database management systems, which are still the most used kind of databases on the planet, have supported us so far. I mean, this is a technology which has already 50 years existed, and it's still a great technology. It supports so many functionalities that have grown over the years: SQL, ACID transactions, triggers, roles-based access control, encryption, security, and of course, Yeah, but we see that these systems have their limits, of course. They are typically monolithic, so you have a single a database server for these kind of databases, which you can, of course, scale up. Okay, getting a bigger virtual machine to put it on, or getting a bigger platform on that. But typically, it's a monolithic system and not designed to scale out for a huge number of customers or users. And of course, they are not much flexible regards the data model. So they're extremely structured. They have fixed field data types, of course, and a strong normalization. So typically data is stored in different tables that you need to join if you want to read it into your application, into your object model. Some people use data wrappers to do so. But in the end, it's costly operations that you need there to get the data from these different tables. So a new type of database should support this better. So having a more flexible data model that supports faster development cycles. And of course, yeah, a data model that allows more flexibility, that's not that overstructured, that allows some sort of relaxed normalization. So getting, for instance, payment information from a user profile and put it just in the user profile record without having it to split up into different tables. So bringing, let's say, the data model also a little bit closer to the object model of my application. And that's a good idea. Have the idea to store data in JSON notation. So, and that's what basically was the answer to the limitations of relational database systems. And NoSQL, not only SQL, is that answer to combine these functionalities together on a platform to deliver performant and agile solutions for modern application. Yeah, but how is a NoSQL different? I don't know if any one of you has some experience with that already. Let's make a quick excursus to that one. So traditional databases, as I said, it's a highly structured set of tables that are related by fields, primary, foreign key, and so on. The data types are defined fixed and make up these relations. And this is okay. It's very structured. It's fine. It's okay. But has its limitations. If you want to have data from different tables, you have costly join operations or need to have several read operations to get all the data from the different tables. And yeah, these limitations can be overcome by a document style of database. So putting data in a JSON format in different documents as records, and giving each of these documents a unique document ID, which is, let's say, sort of a primary key, which you might know from a relational database, but allow to put lists and nests array of data into that record as well, which is typically not done in a relational database. That makes it pretty easy to overcome a very overstructured document model. So what I call this is sort of a relaxed normalization. So you can normalize, you can do joining, can do joins of documents, but you don't have to. So you can nest lists of arrays into a single document. Yeah, and another benefit that we have with NoSQL approach, with this document database approach, is the schema-less operation. Because if you want to use a new information or store new information in a relational database, for instance, let's say you have user profiles and want to add a Twitter address of a user to a record, what will you need to do? You need to change the data model. I mean, in that case, it's a very simple change that you have to do, just adding a field to the table. But you might think of more complex changes. So just a simple sample. And the thing is that typically the programmer is not responsible for doing that change often in an enterprise environment. He has to sync up with his database administrator. So you have a lot of communication also ongoing before you can do this change Not so in the NoSQL world. You would just, as a programmer, add that attribute to the JSON document and store it right away. So there's no need to change a data model. It's just coming up with adding that attribute. So it changes a little bit that the documents might be in different versions. So the programmer, the developer will have a little bit more responsibility to take care about how to do that. But all that, and keep that in mind, to become more agile, to become faster, to become more independent of the data model of the database. And that's, in the end, what brings the benefit here. Yeah, okay. So that was just a short breakout here to that NoSQL, to that JSON document format. And what happened then? After that, we say, okay, it might be good to have a new database type. Tool sprawl all across the stack. So a lot of companies have developed technologies that go away from the traditional relational approach, and they all are available. And the thing is with that one is that the reality too often ends in what I call a Frankenstack monster. So you have a lot of tools and need to shuffle data between these tools. You need to orchestrate them. So it's really a costly process that you have here if you choose different tools for different types of operations. And even if you think about orchestrating them, keeping them up to date on the right newest version and so on, it might be an operational nightmare to develop in such type of a stack. So what would be great would be a platform that combines, a comprehensive platform that combines different types of tools on a single platform, and that's where Couchbase comes into play. So what does Couchbase deliver as a database? And I think that's fair to understand that. Couchbase as a database and data management platform is a combination of functionality. It comes with an integrated memory cache, so data is always written first into a memory and also kept there for later, faster read purposes. And of course, you can use Couchbase as a simple key value database, but you can also have certain relational capabilities and use SQL as a SQL language and query documents by attributes. Full text search is included in there, operational analytics away from the regular operational read and writes, as well as some eventing, so data mutations can start events of certain processes in other systems, in other solutions. And of course, if you think about a global scale, to keep data updated across different regions on the world, there's also the capability of replicate data between these sites, between these regions. And plus, last but not least, also keeping mobile devices up to date and also getting data from mobile devices into a central database. This is something very, very important. If you're thinking about mobile application today, what sucks most at mobile applications? Yeah, typically if you do not have a network connectivity, because most of the applications today work that way, that they communicate with a web service in the back end. And if that's not there, the application is mostly dead. So what Couchbase gives you is the capability to have a local data store on the mobile device and to sync data between that mobile device and a central database when network connectivity is available. And also that makes part of a user experience. If you can deliver the capability to have use cases at hand that people can use also without network connectivity. Think about, for instance, if you have a driving service, and drivers are hanging around typically in garages. And what do they do not have? They do not have connectivity there, and that's where they also can read their schedule from the local database without having to have that network connectivity. Yeah. Okay. What this all brings together is that using a platform rather than single tools for some tasks is that you will be much faster in your development. You will only have one platform to communicate to. You will only have one API that you need to work for, and you will, of course, reduce the operational costs at that point. I think that's a big benefit, and that also brings user experience at a new level. Yeah, so a comprehensive data platform helps to reduce costs, as I said. So how does that look like? If you're looking, for instance, at some customers that are using these kind of platform services, let's pick some examples. Some company called Amadeus, which is the let's say data backbone of all or mostly all travel bookings, airplanes, hotel bookings, and so on. All these searching engines that where we're looking for flights and so on. That's handled through this data backbone. They're using Couchbase, and they have really had really fantastic results with that. They increased their development cycles and went very, very fast now. If you think about Trendyol, this Turkish Amazon selling platform, they are reducing their costs using Couchbase. Azure Commercial Bank within 3. I don't want to get into too much details there, but you see that a comprehensive data platform with multiple functionalities can reduce costs and deliver better user experiences in terms of faster response times, for instance, and data availability in general. Yeah, but when talking about these kind of platforms, everyone thinks, hey, that's a huge platform. I don't have that huge platform. I'm starting with a small business, or I have just an application that works within my company, not for a global scale or whatever. I know that customers start exactly that way. They start for performance reasons mostly and say, okay, I only want to have that performance stuff solved. I only want to have a fast, reliable key value store. Okay, let's take that kind of database platforms. But coming and growing over the time, the typical way is that, and that's also important to understand if you develop a solution, a platform, it's mostly always the same stuff. In the end, sometimes you come at the point, hey, data and access flexibility is something that really brings me forward. And if you scale up, you will find that it's really easy to have a platform that allows this scaling out process. So I have a lot of examples of customers who started, let's say, with a traditional relational database, started with a monolithic approach. It was so nice and easy in the beginning, but then they got the 100th customer, the 1000th customer on their platform and said, hey, that monolithic thing doesn't scale. What can we do? And after that point, to change the platform, it's a hard thing to do for them. And so I would recommend to better go and see how are the needs for scaling up the platform to guarantee fast response times, to guarantee user experience at any scale. Yeah, let's talk a little bit about some typical use cases that you will find if you talk to or talk about applications that are using NoSQL technology. And so we see here typical these kind of user-centric use cases, so such as Customer 360, so seeing most of the customer information at one place. Handling user profiles is a very common use case there. If you think about all these streaming platforms, Netflix, Disney Plus, or whatever you name it, they all have their user profile stored anywhere, and you want to have to access it anywhere from any device. So that's a very common use case. Catalog and inventory management is an important thing, especially for e-commerce systems. But also things like a session store, identity and access management, and of course IoT applications, IoT data management, things like sensor data that needs to be written very fast and stored very fast. Think about the memory cache using there, and as well field service applications with a mobile-first approach of the mobile stack, where you can store also data without having internet connectivity. Think about these windmills for generating power. If a technician goes out there, there might be no network connectivity, but they need to do their maintenance check anyhow and do their protocol in their mobile app, and later sync that data up to the central database when they're back in civilization. Yeah, okay, that's some samples of typical use cases there. But let's also think about complexity. And that's something that I very often see in a lot of companies nowadays still. So it's mostly a ground structure. You have different types of departments. And so development of apps went very fast over the last years. We might have, let's say, somehow developed an application to identify deliveries that come into a store of a company, for raw materials that need to come into production. Then you want to track the production process. Then you want to also do some quality checks and so on. And all these points of a project mostly always have their own application, and all these applications have their own and simple database there. So you got a spread of databases across the company. And if it comes to the way analytics, so if you want to have all these data together, you need to put these data, copy it or streaming it over to some sort of data warehouse, or multiple of them to get an idea. And if you think about real world processes, this is a very, very simple example, very equivalent there. Having some more thoughts on that. Do you really get the data that you want, and so on? If you think and talk about that, you might find in a lot of companies similar examples. So what about putting all this data into one comprehensive platform? So why not putting everything in one platform, not in one database, but in one platform instead of single servers at every point that need to be operated separately and so on. And that's exactly the approach that we saw here. So also here, this process complexity that we have seen can be dramatically reduced by using a comprehensive data platform that delivers this functionality and can scale also for these number of processes and data that comes from there. Yeah. But getting back to the question, hey, can we have that at a global scale? So what about huge enterprises where you have distributed data among the globe, where you have some user profiles that need to be available at different sites? So you do not want to load your user profile from a server that's at the other end of the world. It might be some more latency there. And it's important to have the capability to, first of all, have that platform available in different clouds. That's a good way to also avoid a vendor lock-on. So, for instance, to be capable to have that product on Google Cloud, on Azure, on AWS, and maybe also where you do not go to cloud, have it on-premise installation. But the most important thing is to have some, let's say, sort of control plane that allows you to control all these implementations worldwide, and also to have a replication process between these sites to get data from one site to another. And that's something that's also part of the user experience, to have your data anywhere at the same low latency that you want it. So if you travel from here to another region, you might want to use your, let's say, Netflix account there and have the same fast access to your user profile. Yeah. And that's exactly what this geo-replication service is all about, so that you can replicate data between different data centers, between different clouds. And yeah, Couchbase is available in multiple regions. That's just a quick overview, but I don't want to get deep into that one. Okay, then I've talked about mobile and IoT use cases. So let's take a look at that one as well. So, yeah, as I told, one of the issues of mobile applications is lack of connectivity. So what if I cannot access my data, the application might be dead. So that's the typical online approach. We prefer the offline first approach, and also be capable to sync data between mobile devices. So also that is a capability that Couchbase Mobile Stack comes with, as well as with some security such as encryption, field level encryption in a database, and so on. And that brings us to an overview of the Couchbase mobile architecture. I quickly want to show you here. So if you're thinking about Couchbase, our product Capella, which is the product which we offer as a managed database as a service from the cloud, so that you do not operate your cluster on your own. You just go to the AWS, Azure, or Google Cloud marketplace, and okay, hey, let's buy that one from there. Then we can go here and put the local database on a mobile device, which we call Couchbase Lite. And this product is capable to sync over to the central database cluster in a region. Mobile devices or IoT devices that use Couchbase Lite are also capable to sync data between each other. So thinking about a use case that we have built for Emirates Airlines. So if they have a ground check of their airplanes that has landed on the airplane, the engineers that walk around with their iPad there, they do not have that network connectivity to their central corporate network, but they have a Bluetooth connection between these devices that can exchange the data. So they're syncing their maintenance questionnaires that they fill up. So each engineer sees what the other engineer does, and that's also a great stuff there. But we also had a use case at United Airlines. They do their in-flight shop stuff with mobile devices, and when they're back on the ground, they sync all the stuff, all the data they had there, all the sales they made there to their central cluster. Yeah, okay, so how do we do that basically? We've seen here the mobile architecture, but let's also take a look at how Couchbase Capella looks in general, so that you also get an idea how this technically works. When we're talking about these integrated capabilities, what stands technically behind that? So actually, Couchbase is a cluster. It's a shared nothing architecture that relies on regular hardware virtual machines, but also capable to put it on a Kubernetes stack as well, or get it from the cloud. But in the end, it's single nodes that make up a cluster, and you can just distribute the functionalities, the services, among these nodes as you need it. So you can isolate the workloads of different services from each other, and but keep it all in the same cluster. So that's also easy for the programmer. If you go there as a developer and connect to a service, you just connect to the cluster. So you do not need to address a specific node of the cluster. You always talk to the cluster, and the client then gets information which node delivers the functionality. So that's really a comprehensive data platform, and it can distribute the load among that, and that allows also horizontal scaling. As I already said, traditional databases, they can scale up, but they cannot scale out, and that's basically what Couchbase makes a difference here from these relational databases. And if someone wants to see how this distribution of the data looks like among these nodes, I've done some detail here. So typically the data, the documents that you put in there is shared among the nodes of the cluster. So I've made this here with an example of 30 points here. You can have, well, replica of the data, so the data can, from one node, can be distributed among the other nodes. So a node can fail, and still have the replica that comes active from that node on other nodes. After that, you can rebalance it. You can add a new node and put then the data right back in the right order. But you will always be able to use the cluster and not lose data. That's the important thing. Yeah, and that's maybe the final slide I want to show here. This is the all-over functional architecture. Very simple here at that point, where you see in the middle the Couchbase Capella cluster. You see the control plane where you can control multiples of these clusters in multiple regions, in multiple clouds. So it's a multi-cloud approach. You see how mobile applications fit into that, how classic web clients and web services would address the cluster, and of course replication. But that's the big picture in a small slide here at the end as a summary. So I want to give you some time also to ask some questions. Oh, I keep the architecture slide here. Yeah, are there any questions? I see here from the web community, there's a question: how fast are the response times for queries? That's a good question. I've talked about a lot about performance. What are we talking about? So it depends, really, to give an answer to that. It depends if you do a key value operation, which means you call a JSON document by its document ID and read it from the cluster. Then we talk about a few milliseconds of response times. If we're talking about queries, we're in let's say still in the millisecond range, depending on the complexity of the query. And of course, then the third level would be analytics queries that might be, if there are lots of aggregations to do and things like that, we might get into the range of seconds. But that's more for longer term run query, independent from the operational. Yeah, so any further questions there? So I'm in between you and the break. Okay, well, thank you very much. And I think I'll give you some 2 minutes back and wait. Thank you.